So this is question number 43 of chapter number 6. You can find it on page number 140. The question says that calculate the kVAR, which is actually the reactive power, or Q, taken by a 20-kilometer long cable mentioned in problem number 42. So this is the same cable as in problem number 42, and the information about that cable was that it had a sheath diameter of 5 centimeter and the conductor diameter of 2.5 centimeter. So this information will be taken from question number 42. And then it says that when it is connected to a 10 kilovolt 60 hertz frequency source, we have to calculate the Q when it is connected to this source. Assume that the epsilon R, which is approximately 3 for the installation. What will be the kVAR, or the reactive power value, if the supply is very low frequency AC of 0.1 hertz? So in the second part of the question, all you have to do is just replace the 60 hertz with 0.1 hertz. So to calculate the reactive power, we actually need the charging current in its formula. And to calculate the charging current, we actually need the capacitance of the conductor. So to find the capacitance of the cable, the formula given to you in the book is that 10 to the power minus 9 times epsilon R divided by 18 times natural log of sheath radius over conductor radius. And the unit for this formula, this derived formula, is farads per meter. So just plug in the values here, substitute the values of everything which is given to you in the question. This 5 and 2.5 centimeters is taken from problem number 42. And you will find out the capacitance to be 2.4 multiplied 10 to the power minus 10, and the unit will be farads per meter. The length of the cable is already given to you as 20 kilometers. So you just multiply this with 20,000 meters and you will get the value of the capacitance in just farads, which will be 4.8 multiplied by 10 to the power minus 6. And then we can substitute this value of capacitance in this formula to find the charging current. The charging current says the charging current can be found by the formula J 2 pi F C, which is the capacitance, times the line to neutral voltage. So you can just plug in the values of frequency as 60. The capacitance will be 4.8 multiplied by 10 to the power minus 6. And this is the line to neutral voltage. The one which is given to you in the question is line to line, just divided by square root of 3. And just calculate, and you will find the current to be J 10.5 amperes. Now you can substitute this charging current in this formula to find the total reactive power for the three-phase system. You just multiply 3 with IEC with natural log. Sorry, the line to neutral voltage. Just substitute these values and you will find the reactive power to be 181294 VAR. But the question is asking you to find kVAR, so we'll just convert it by dividing it with 10,000 actually. No, 1000, because we have to convert the VAR into kVAR, so just divide it by 1000 and you will get the answer of Q to be 181.3 kVAR. And now for the second part of the question, it just says that do calculate the same Q if the frequency was 0.1. So just replace this frequency of 60 by 0.1 and you will get the value of charging current to be 0.017 amperes. And then use this current in the formula of the reactive power, and you will get the reactive power to be 0.3 kVAR. From 181.3 to 0.3 kVAR by just reducing the frequency from 60 to 0.1, or VLF, or very low frequency.